Before we dive into tonight's story, say hello to Puppy, Orange's resident lobster assistant, always clawing through the noise to find what actually matters in the semiconductor world. Puppy doesn't just pinch headlines, Puppy reads between the silicon layers. Tonight, Puppy dragged something big out of the deep, a quiet cancellation that might reshape how the entire AI infrastructure build-out unfolds through 2027 and beyond. Tonight's story comes from Tom's Hardware, citing a report by SemiAnalysis, one of the most technically rigorous semiconductor research firms covering the AI accelerator space. According to that report, Nvidia has made a significant internal decision. It is canceling the quad-die version of its Rubin Ultra GPU, the flagship AI accelerator that had been planned for a 2027 launch. The reason cited in the report is not a market shift, not a customer demand change, and not a competitive pivot. It is described specifically as concerns over manufacturability and manufacturing execution. That framing is important, and we will come back to it. To understand what was cancelled, you need to understand what Nvidia was originally building. The Rubin Ultra design with 4 compute chiplets was described as one of Nvidia's most ambitious GPU projects in recent years. The baseline Rubin architecture already uses 2 compute chiplets, so the Ultra variant was essentially doubling that count, stacking 4 chiplets together to deliver a level of raw AI compute performance that would have been unprecedented in a single GPU package. This was not an incremental upgrade. It was Nvidia pushing the architectural envelope as far as it could go, betting that packaging technology could keep pace with its performance roadmap. The cancellation reason, manufacturing execution concerns, is a phrase that deserves serious attention. It does not mean the chip was poorly designed on paper. It means that when Nvidia and its partners stress-tested the feasibility of assembling 4 chiplets into one coherent, high-yield, thermally stable, and electrically reliable package at scale, the risk profile became unacceptable. Quad-die designs exponentially increase the number of interconnect points, the thermal management challenge, the testing complexity, and the probability of yield loss at every stage of the packaging process. Nvidia's decision to pivot to a dual GPU design instead suggests the company concluded that 2 separate dual-chiplet GPUs, working in coordination, can deliver comparable system-level performance with dramatically lower production risk. This is where the story lands squarely on Taiwan's doorstep. TSMC's CoWoS advanced packaging platform is the foundation upon which Nvidia's multi-chiplet GPU strategy is built. And the complexity ceiling of CoWoS is precisely the kind of constraint that would drive a quad-die design toward manufacturability concerns. If Nvidia is pulling back from 4 chiplets to 2, that is a signal that even TSMC's most advanced packaging lines are operating near the boundary of what can be reliably executed at data center volume. For Taiwan's advanced packaging supply chain, including substrate suppliers, interposer manufacturers, and CoWoS capacity allocation, this redesign means a different demand profile than what had been anticipated for the 2027 cycle. A quad-die Rubin Ultra would have required an extraordinary amount of HBM memory stacking and thermal dissipation infrastructure around it. Shifting to a dual GPU design changes the memory bandwidth architecture, the power envelope per package, and consequently the cooling requirements inside AI server racks. For Taiwan's AI server assembly ecosystem, companies building the rack-scale systems that hyperscalers deploy, this is not a trivial change. Liquid cooling designs, power delivery boards, and interconnect topologies that were being scoped for a quad-die monster now need to be reevaluated. The supply chain does not just follow chip specs, it pre-invests in them, and a late-stage redesign creates both risk and, for agile suppliers, opportunity. Here's the question tonight's story forces us to ask. Has the AI infrastructure industry been pricing in a chiplet scaling trajectory that the packaging ecosystem was never actually ready to support on schedule? Nvidia's roadmap has been presented to hyperscalers, investors, and supply chain partners as a reliable staircase of performance gains. But if a flagship product gets redesigned over manufacturing execution concerns this close to a 2027 target, it raises a harder question. How many other next-generation AI chip programs across the industry are carrying similar hidden execution risk that has not yet surfaced publicly? The second blind spot worth examining is the assumption that canceling the quad-die design means Nvidia is weakening its position. That framing misses something. A dual GPU system that is manufacturable at scale, ships on time, and achieves high yield may outperform a quad-die system that ships late, yields poorly, or fails in the field. Nvidia's real competitive moat has never been purely about peak theoretical flops. It has been about delivering reliable, software-optimized, ecosystem-integrated compute at hyperscaler volume. The Rubin Ultra redesign may actually be Nvidia choosing execution discipline over architectural showmanship, which is a different kind of strength than the headline suggests. The most powerful chip is not the one with the most dies on paper, it is the one that actually ships, yields, and scales inside a data center. If you want to keep tracking where the real semiconductor and AI infrastructure story is heading, subscribe to Orange 888TW and follow Orange News, because Puppy will keep pulling the signal out of the noise, one claw at a time.